In previous lectures regarding stock valuation, we have understood that dividend discount model is a model that would predict the current price of a stock on the basis of its future dividend. So now then we understood that there are different types of model within dividend discount model: the zero growth model, the constant growth model, and the non-constant growth model. We have already understood the zero growth model. We have covered the theory or basic concept of the constant growth model, which is called Gordon growth model. In this lecture, we are going to understand constant growth model, its examples, and then what are the limitations of constant growth model, and then what non-constant growth model is, and basic understanding of that non-constant growth model. So let's move to the next slide. So we have already understood a stock whose dividend are expected to grow forever. When this is the situation that we are going to use the constant growth model, and we know that dividend for each year would be different because of this growth factor. So D1 would be different than D2, and D2 would be different than D3. We have already seen this example where the company paid a dividend of 1.5 per share, and we need to find out its dividend for in 4 years if the dividend growth rate was 5%. We saw this formula, which is the formula of finding the P naught, or the current present value, or the current intrinsic value of a stock based on this growth factor, where we have this D naught into 1 plus G divided by R minus G, where this factor is basically nothing but D1. So this is D naught into 1 plus G would be equal to D1, the dividend of next year, divided by R minus G, where R stands for cost of capital, G stands for growth rate, and the dividend D stands for the dividend. So let's solve an example, and it would be more clear to us. So this is the example that will help us understand the constant growth model and how do we find the intrinsic value. This example is related to agro fertilizer. The agro fertilizer just paid a dividend of 2.30 rupees per share. So whenever they say that they just paid the dividend, we immediately know that it is D naught. This zero stands for the current or the previous time period, right? It is for today. When we say D1, so it would be the dividend of next year. So it's rupees 2.3 per share with constant growth of 6%. So this is our G, and the cost of capital is 7%. This is our R. Remember, the R is have different names. It can be called cost of capital, required rate of return of the investor. In bond we called it yield to maturity, and so on and so forth. But when we discuss the cost of capital or the WACC the WACC topic, then it would be more understandable that why there are different names to it. So what we need to do with this example, we need to find the intrinsic value for the agro fertilizer, and then we need to make a decision whether that stock is undervalued and overvalued, and based on this understanding of over and undervalued, we would either buy it or sell it. So let's move towards the solution. This is our equation. We have just seen this equation. Remember, we said P naught is equal to D naught into 1 plus G divided by R minus G, and we have already mentioned that this D naught into 1 plus G means D1. It is the, what we are doing here is basically we are adding the growth in dividend into this D naught. So let's say previous year's D naught was 2.50. So if we find what additional growth amount is and we add to it, then it would be called D1. So this is nothing but D1. So our basic formula to find the P naught of in case of constant growth model is D1 divided by R minus G. So then we just mention that what D1 is equal to. It is equal to D naught into 1 plus G. So putting in the values, we know that P naught, D naught in previous example it was 2.30, right? This is D naught. Here we have already discussed it. The D naught is 2.30. The growth rate is 6%, so 0.06, divided by R is the cost of capital, in this case is 7%, and minus G, which is again 6%. So if we simplify this equation, the answer would be 243. Now what does this 243 represents? It means that the stock's intrinsic value is 243 rupees, right? Based on its dividend. According to dividend discount model, we have analyzed that this stock is currently worth 243 rupees. Now should we buy this stock from the market or not? Now let's get back to the previous slide. Here it mentioned that currently this specific stock is being sold in the market for 250 rupees. Remember, we just discovered that its current value its current worth is 243 rupees. So what would you say? Is this stock undervalued or overvalued? How do we make the decision? Our decision rule was, if the market price is greater than, market value is greater than the intrinsic value, then we say that it is overvalued, right? Overvalued. And when the market price is less than intrinsic value, then we would say that it is undervalued. So here, when this is the case, when it is overvalued, we sell it or we don't buy it. If we do not have it, if we have it, we sell it. If we do not have it, we do not own it, then we don't buy it from the market. When this is the case, when market price is less than intrinsic value, we buy it. Or if we already have the stock, then we hold it. We hold it till the market value is equal to the intrinsic value or higher than that. Okay, so in this case, the market price is 250 and the intrinsic value is 243. So market price is greater than the intrinsic value. So that means something that is worth 243 rupees is being sold in the market for 250 rupees. So obviously you wouldn't buy something that is worth less and it is being sold for a higher price. So in this case, this stock is undervalued and we would sell it if we own it. If we do not own it, then we wouldn't buy it, right? So I hope that this is clear. Let's move forward. This is another example. But here you have to understand there's a trick in it. Okay, the next dividend of PPL stands for Pakistan Petroleum Limited, will be rupees 5 per share. Now, is it D0 or D1? It is D1. Now, how do I know that it is D1? Remember, this is the key point. The next dividend. When they say that next dividend is this much rupees, then it is the D1. Or let's say if they say that a dividend after 4 years would be 5 rupees, then that would be D4, because it is a dividend after 4 years. So this numeric number represents the time period. So the growth rate of PPL dividend is 7%. This is RG. If the investor requires 16% return, this is RR. Then what is the value of PPL stock today? So we need to find what? We need to find P0. We know that the formula of P0 is equal to D1 divided by R minus G. We will look into this one in a minute. But let's solve the first aspect of this question, and that is the value of PPL stock today. So let me solve it here. This the formula we know is D1. D1 in this case is 5 rupees. So in this case we already know the D1. We do not have to calculate it again. Divided by R minus G. R is 16% and G is 0.077%. So the answer would be 55 rupees. So that means this stock is currently worth 55 rupees. So if we are going to buy it, we shouldn't buy it for a price higher than this 55 rupees. So anyhow, we have found P naught. This was the easier part. We have already done it in previous example. We know it. The tricky part was understanding this aspect, which is that the value had already been given. So the next part of this question is, what is the value of PPL in 4 years? So what essentially we need to find is this thing, P4. Before we move forward to the solution, I would like you to think that what should P4 be equal to? I mean, if P1 is equal to D1 by, if P1 is equal to D1 divided by R minus G. So what we are doing is we are finding the current price based on the future dividend, right? So if we are going to find the P4, then the dividend that we need to use should be the future dividend, which is D5 divided by R minus G. That part is the same. So let's move towards the solution. So this is what I have written in previous slide, which was D5 divided by R minus G. And if we simplify this, so this would be equal to D1 into 1 plus G. So we can write it in different ways that would depend on the question. Say for example, if in this case the value that of D we had been given is the D1, so we already know D1, so we have to build our equation on the basis of this D1. So that's why we have written D1. So we start with D1. So how many number of years do we need to compound it or grow it? We need to grow it 4 years by 4 years, so we would have this D5. So imagine if we, in this question we had D0, if the sentence was that the previous dividend that was paid was 5 rupees, then in that case, to construct D5, then D5 would have been equal to what? It would be equal to D0 into 1 plus G raised to power 5. Right? So because we had the value of D0, so we compounded it for 5 years to get the value of D5. If imagine we had D3, imagine the sentence was that the dividend after 3 years would be 5 rupees, right? So if you wanted to calculate D5, then D5 would be equal to D3 into 1 plus G raised to power 2. So that would be equal to D5. So that depends on the situation, but the basic idea is that whatever stock price for whichever year we are going to find, we are in equation we are going to use the next year's dividend. So this becomes our equation. It's better to write an equation first. It makes it easier to solve. Moving on, we know D1 is equal to 5. After we have written this equation, it becomes pretty, just plug and play kind of solution. So we just plug the values into this equation. The D1 was 5, G was 7% for, and when we solve this thing, we get the value of 72. So what does this 72 mean? That the intrinsic value after 4 years would be equal to 72 rupees. I repeat that the intrinsic value after 4 years would be 72 rupees. There is another way of doing this question. and that is by using this equation. Remember, we needed to find what P4. We can find P4 using this method, and this is another method to use to find to solve this constant growth model. And what this equation tells us that P4 would be equal to P naught into 1 plus g raised to power 4. So what it means is that the stock price will also grow at the same constant rate as dividend. So dividend is growing at the rate of g, the price of the stock will also grow at the rate of g. So if we have P naught, we simply find the P naught, or we have already found it in previous example in the part 1 of this question. If we know the P naught, we simply grow it for 4 years and it would become P4. Let me get back to P naught. This was the P naught that we found, 55. So if we put the values in this formula, it was 55 into 1 plus 0.07 raised to power 4. We must get the similar P4. So the P4 that we get using this new equation, the second method, is 72 rupees, and the P4 value that we got using our first method were also the same. So what it essentially means is that the price of the stock would also grow at the same constant rate at which the dividend is growing. So whichever method you use, they both are same. So whatever you think is easy, you can use it. Okay, here comes our second topic of the limitations of constant growth model. Now the issue with constant growth model is that we cannot use constant growth model when g is greater than the cost of capital. Say for example, in previous example, the g was 7% and cost of capital was 16%. That's fine, g is less than cost of capital. So we can use constant growth model to find the price. But when the growth rate is higher than the discount rate, then we cannot use this constant growth model. Now what would happen, imagine if growth rate is higher than the cost of capital. When that would happen, imagine in this case, instead of this thing, imagine that the cost of capital was 0.07 and the growth rate was 0.16, 16%, the opposite of what we already had. Then what would happen is that denominator would be equal to minus. It would have minus sign, and when we divide this 6.55 by minus 0.09, we would get an answer in minus, and that wouldn't make sense. The stock wouldn't have a price in minus. The minimum price a stock can have is zero value. So numerically, you would be able to solve it, you would get the answer, but theoretically it wouldn't make sense. So the limitation with this constant growth model is that we can only use this model when the cost of capital, or R, is greater than G. We shouldn't use this model when the opposite is the case. Second limitation of this model is that the G should be constant. We know that G is 7% in our previous example. It means that each year the dividend will grow by 7%. Now what if in few years the dividend would grow by 7% and in the other years the dividend would grow by, say, 15%? So that means that the growth, there are multiple growths. There isn't a single growth that we can cater into the formula. So we have G1 and then we have G2. So when we have these limitations, we cannot use constant growth model. What should we do? We currently do not have any solution for this case. But when this is the case, when we have multiple G's, when there is no single G, when we have more than one G, then we can use another type of model which is called non-constant growth model, or multiple growth or two-stage growth model, which we are going to discuss in next lecture. So to solve this problem of when G is not constant, or we have multiple G's, we have multiple growth rates, then we are going to use the non-constant growth model, and that is the topic that we are going to cover in our next lecture.